Hello there, it is me again, Mr. Downs, and I am here to teach you today about double-digit multiplication. Specifically, we'll be doing the area model of double-digit multiplication. A lot of students actually end up really liking this method because it's pretty quick to calculate, and sometimes it's actually faster than the regular way of the old algorithm of using multiplication. Your parents are probably familiar with the traditional algorithm, which we'll be talking about tomorrow. I've gotten to the point where I actually use both pretty much 50-50. Depending on the number, I might use the area model, what I'm showing you today, or I might just use the regular standard algorithm that I learned when I was in 4th grade. So let me show you what that looks like. Let's say we had a number we wanted to multiply 47 times 36. There's the algorithm that we'll do tomorrow that was one way to do it, but today we're working on the area model of multiplication. So what I would do is I draw a 4 square, ones and tens and ones and tens. Okay, well actually tens and ones and tens and ones. And then I break both of these numbers up. So I know that I'll put it over here so maybe you can see it better. Let's go down here. I know that 47 is the same thing as 40 plus 7, and I know 36 is the same thing as 30 plus 6. So what I'm going to do is I'm just going to arrange these on my 4 square before I multiply. So I know 47 is 40 plus 7, and I know 36 is 30 plus 6. So then these numbers on the top multiply down, and these numbers on the side multiply across. So my first box, I always just like to start with this box. 40 times 30, well, 4 times 3 is 12, and then I have to add on 2 zeros as pretty little presents. 1,1200 is the answer to 40 times 30. Then I do 40 times 6. Well, 6 times 4 is 24, and then I just add the 0 on. This one over here would be 30 times 7. Well, 3 times 7 is 21, and I just add a 0 on the end. And then find my last box, 7 times 6 is 42. Now these are what's called partial products because they are each partial or part of my answer. So then to get my final answer, all I have to do is add all those up. The great thing about the 4 square method is that you don't have to deal with any regrouping. And sometimes the student, you might have to do some addition regrouping, but sometimes with the other algorithms, students just kind of get confused with all the different steps involved. But this one, it's just a lot more visual and laid out for you. So 0 plus 0 plus 0 plus 2 is 2. 0 plus 4 plus 1 plus 4 is 9. 2 plus 2 plus 2 is 6. And then bring down my 1. So the answer to 47 times 36 is 1,692. Let's try another example. All right, so think of a number. This is cool. Think of a number in your head, and I'm going to read your mind and know exactly which number you picked. Do it. Think of a number. 3, 2, 1. 54. I guessed it. 54 was the number that you had in your mind, and I know it was in there. Now, next, I want you to guess what number I'm going to write down. Think of the number that's in my head. I don't even know yet. All right, 23. Did you get it right? Maybe. So what I have to do now is I make my 4 square, and truthfully, you don't have to break it up. I just break it up by tens and ones because that's really easy for me to do. Like, you could break 23 up into 10 and 13 if you wanted, and that's just fine. I just find it's easiest to break it up by tens. So I know that 54 is the same thing as 50 plus 4, and I know that 23 is the same thing as 20 plus 3. Now, this number can go on the side and that number can go on top. It doesn't matter as long as the 50 and 4 stay together and the 20 and 3 stay together. They can go on either side. These ones on the top multiply down. These ones on the side multiply across. So with this one, 2 times 5 is 10, and then I have 1, 2 zeros that I need to add on. 20 times 50 is 1,000. This one is going across. This one's multiplying down. 3 times 5 is 15, and then I need to add on a 0 because I'm multiplying by 5 tens. Over here, this one would be 20 times 4. So 2 times 4 is 8, and then I add on a 0 to equal 80. And then last but not least, 4 times 3 is 12. Now remember, these are called partial products because they are part of my final answer. So what I do is I just add these up. 1,000 plus 150 plus 80 plus 12. Make sure that the place value on these is nice and straight, because if the place value is off, you will add them wrong and it'll be incorrect. So ones, tens, hundreds, thousands. Make sure that it's straight up and down. 0 plus 0 plus 0 plus 2 is 2. 5 plus 8 is 13, plus 1 is 14, so 4 in the basement, 1 in the attic. 1 plus 1 is 2, and then I bring down the 1. 1,242. And then the way you could check this is just by double checking each of these 4 quadrants to make sure that it's done correctly. But the nice thing about this is that you only ever have to do a basic fact. We just did 2 times 5 and added 2 zeros on it. We did 2 times 4 and added 1 0. We did 3 times 5 and added a 0, and then we do 3 times 4. So you only ever do basic facts, and you don't have to worry about some tricky regroupings or anything like that. So that's what makes this method efficient. Let's try one more example together. All right, this example, let's do 37 times 29. So remember, I'm going to draw my 4 square out over here. I'm going to draw my 4 square, and this one's going to have 30 plus 7, and then 20 plus 9. So 20 plus 30, or 20 times 30, 2 times 3 is 6, and then if I add on 2 zeros, that would be 600. This one, 3 times 9, would be 27, and then I add a 0 on, I'd get 270. This one is going across while this box goes down, so 20 times 7 is, oops, I almost put 27 down, I almost added 14, add on my 0. And then this last box, the 7 multiplies down while the 9 multiplies across. So 63. So just remember, these top ones go down, these side ones go across. So this one was 20 times 30. This one was 30 times 9. This one was 20 times 7. And this one was 9 times 7. And then all I have to do now is add up my partial products. So 600, 270, 140, 63, making sure that my columns are all lined up nice and neat. So 3, 17, and that's 10, 1073. So good luck on the area model of multiplication today. I hope things go well, and if you have any issues, make sure to drop me an email. But thanks so much for watching. Bye-bye.